Hello, statistics students. This is our second video lesson on frequency distributions and how to graph them. Rather than giving you the entire lecture on video, what I'm going to do is kind of go through quickly all of the slides that I have. Feel free to pause the video to as long as you need to copy them down. And then we'll spend most of our time in class discussing and explaining and clarifying, but you'll already have the notes written down. So let's get started on that. So we've already talked about our classes, and we know how to find the class width, for instance, and we also know how to find the upper and lower class limits. Well, what we're going to do here is we're now going to find the class midpoint, which you just average these two numbers. We can also add, well, we already have frequency on our distribution. So far our distributions only look like the upper limit, the lower limit, and the frequency. Now we could add midpoints if we so desired. We could also add relative frequency. Relative frequency, you just take the frequency and divide it by the total number of data points. Well, the total number of data points is the sum of all the frequencies. So if I have these data points, that adds up to 23. So 3 out of 23, rounded correctly to the nearest percentage point, is 13%. Please confirm that. And please, when you do this, round correctly. 4 out of 23 rounds to 17%. If you're with more than 1 percentage point away, you've probably done something wrong. So these are rounded numbers. They came up to 99%. That's okay. If yours added up to 97%, I would suggest going back and redoing it. Well, before I switch that, again, take a look at relative frequency and what it means and how we calculate it. Now, this should interest you. How does that relate to John Grant's table that was on, I think, page 2 of the handout, which not so coincidentally is the subject of our upcoming quiz? If you can't answer that question, please be sure to raise your hand in class, and let's get that clarified. There's also cumulative frequency, where you keep a running total of how many data points you've encountered so far, such that by the time you get to your last class of data, your cumulative frequency should add up to all of your data points, your N. And for whatever reason, the lights just went out, so I'm going to pause this recording and go turn the darn lights on again. I'm back, and you have no idea how long I was gone. I love that. Okay, next part, class boundaries, are discussed on page 44 of our current textbook. And what the class boundaries do is they make sure there are no gaps. You might recall in one of our recent slides here, we went from 1 to 5 and 6 to 10. Well, if you're graphing these on a histogram, you don't want there to be a gap between 5 and 6. So what class boundaries do, if we were to do one for this data set, there's a gap of 1 in here. This class would go from 1/2 to 5.5. This one would go from 5.5 to 10.5. So in other words, you just kind of split the differences on these intervals. And here's what it looks like. So here's a class limits. I have from 65 to 104, I have 6. Then there's this gap from 104 to 105, and there's a gap here from 144 to 145. We don't like that. It's gonna be stinky. We don't want that. So using the same data with class boundaries, I'd bump this down to 64.5, this up to 104.5. Now my boundaries, or my rectangles bump up against each other. You can also graph these rather than with the endpoints, rather than with the class boundaries, you could graph with the midpoints if you want to. Sometimes that's helpful. Most of the time it's not, but there are times when it is helpful, and we'll discuss that in class if you ask about it. So that's it for this video. Make sure you've copied all the notes down so that we can discuss it in detail in class. And have a great one.